Good afternoon, everybody. I'm very happy to be here and to talk to you in a little bit more detail on hazard resilient water systems. I think Mrs. Martin set this presentation up quite well. She kind of gave an overview of some aspects of resilience in water. And I'm going to go a little bit more into detail, but as you'll notice at the end of the presentation, I'm going to point out there's still many things that I'm not going to cover. I'm going to give a high-level overview. And then a little bit about myself. I'm listed here as C.A. Davis Engineering. That's a company of one, me. And that's because when I retired from the Los Angeles Department of Water and Power, after 32 years of work there, I couldn't just sit around and watch soap operas, so I continued doing work. So if there's things that we could talk about that I could help you with, please let me know. I'd be happy to talk later if this interests you. So what I'm going to talk about here is what is a resilient water system. I'll give you a definition and some characteristics of what a resilient system entails. I'll talk a little bit more about water system services, and then hazard resilient pipelines and networks, and then I'll give you some references and bibliographies of other things that I'm not able to get into here. So again, a little bit more about my background. Before I retired, I was the first resilience program manager for the LA water system. And I'm not certain of this, but I would certainly do know that I was one of the first resilience managers for a utility in the United States, if not around the world. And so what that required me is to think about what is a resilient water system. Because I was assigned a position, but nobody really knew what it was. So you're going to get some benefit of that thinking process and me engaging with many people, not only in Los Angeles, but all around the world, trying to figure this out. Okay, so I'll go over some of this. So let's start with a definition. This may be a definition you've never seen before. So it's a working definition that I use and has been accepted by a lot of different people in its concept. What is a resilient water system? So it's one that's managed to provide safe and reliable services to customers and users, cope with chronic stressors, and accommodate hazard-related impacts with the ability to continue providing services or limit service outage times tolerable for community recovery efforts. So you notice the word services is really important, and I'll get back to that a little bit later. And it also actually requires another definition. So what is tolerable to a community? So how long can you go without the appropriate services? How long can you go without meeting water quality requirements? How long can you go after an earthquake without getting any water at all to a hospital? These are questions that are very difficult to deal with by all water systems, because none were actually designed to be resilient. We're trying to make them resilient now. And how do you manage this? This is a big issue. So hopefully some of this information helps. So we'll start with that definition, and now I'll go to what makes a water system resilient. Well, here's just some ideas that help you understand whether you're getting more resilience into your system or not. But there are some common characteristics possessed by resilient water systems, and they are that they are stable and well managed, maybe something along the lines of what we just heard in the last presentation. They have a good managed organizational structure. They have adequate support and resources. They have financing for daily and unexpected conditions. They have staff that's well-trained, competent, and sufficient in number. So they're not understaffed. They're appropriately staffed, not overstaffed and spending too much money on resilience, but appropriately staffed. They undertake emergency response planning. They have a commitment to continuous development and improvement. A resilient water system has established performance and recovery objectives, something that almost none really have. So something that we need to work on and create. What are your recovery objectives when you lose services, when you get those back, and to who? I'll go over that a little bit more. They're aware of the threats and the hazards and implement mitigation measures to lessen the impacts from these threats and hazards across their system. They are prepared to provide emergency water when the water is not available through their network. So how do you get potable water to people that need it within the 3 days before they perish when you can't provide it to their house? These are important things to think about. They understand the community needs, and they engage with the community. Some good practices that are utilized by resilient systems are they implement risk management. They implement asset management. They replace the assets when appropriate with the appropriate materials to improve the resilience of their system as they're replacing it. So you saw a map of a pipe replacement program in the last presentation. A resilient water system, Sierra Madre is actually an earthquake zone, so I would pose Sierra Madre would be looking to see if some of those pipes should be more earthquake resilient. Or if you're in a flood hazard zone, are they more flood resilient so they don't get eroded out and fail in those services if you're in a flood zone? And they utilize the resilient materials when they're doing that. They have continuity plans, so that would be business continuity or continuity operations. They have emergency response drills and exercises. They implement safety protocols during the disaster, not just before and after, but during as well. Water resource, they implement water resource and water quality management, which is of course a huge field into itself. But you have to think about it in terms of the disaster that may strike. They have consistent standards and guidelines, and that's important because almost all guidelines, turns out, are not consistent in the way we design our systems for the different hazards. They actually have total discrepancies where if you implement one standard, you're anti to another hazard. So we don't have a good handle on that probably very well anywhere in the world. And they also provide leadership they have leadership, I did that backwards, sorry. They have leadership that provides consistent direction across the entire organization. And we need to understand resilient to what? You're not just resilient, you're resilient to something. You're resilient to the unknown, and you're resilient to the known. So you have to be prepared for the unknown conditions, and you have to be prepared for those that you know you're exposed to. So if you're in Sierra Madre and you're crossing the Sierra Madre Fault with a pipeline or any other system, you're prepared so that when that ruptures, you can limit the damage. Sorry for picking on Sierra Madre. You can limit the damage and you can recover the services to the people when they need it. So the expected and unexpected include the natural hazards, the technological hazards, and the human-caused hazards of all types, like all kinds of human threats. You continuously review the multiple hazards that may strike and try to address them in one solution that can address multiple hazards is really good for resiliency. And you implement cost-effective improvements that can address those multiple hazards. So I just gave an overview of some of the most important initial things that you need to address, but this paper I'll refer you to, and it's in your book. I'm really pleased to see that the presentations were there because I made this hoping that somehow these slides would be made available. There's 17 characteristics listed in this paper, and 120 achievement indicators that if you're able to possess those achievement indicators, then you're acquiring these characteristics of a resilient system and continually improving over time. Those are all listed in here, so I refer you to those. Now, back to the services. Resilience, to me, is all about the services provided. We wouldn't have a water system if we weren't trained to provide services to your customers. We're really all about the services. So a hazard strike like a monsoon, a landslide, a drought, earthquakes and so on can cause damage to water systems and or negatively impact the water supply and the water quality. So the damages and impacts disrupt the services to the customers in some manner for some length of time. The service losses prevent the restoration. The service losses and restorations need to be prioritized based on what the customers do. So not all customers have the same priorities. And a simple example that's very easy to understand is a hospital is more important in a disaster than a sports complex. maybe two ends of the spectrum. So you just don't start restoring services. You restore your services to those that need it to help the community become more resilient. The water system is not resilient if the community is not resilient. They go hand in hand. Okay, so basic water services. We don't just supply a single service. You know, on a non-rainy day or non-shaky day, we all take it for granted. We go, turn on the water tap, we say we got a water service. That's true. But in reality, you have 4 water services coming out of that tap. You're getting the water, you got water delivery, you got water quality, you get the quantity of water you need, and that quantity with the volume and the pressure can fight fire. Of course, this is in a typical distribution system. If you're a wholesaler, it might be a little bit different, but some water systems vary, but usually we're talking about distribution systems in cities. So we need to think about that. There's a formal definition there, but basically you can summarize it. Do you have water? Is it safe to drink? Is there enough of it? And can it fight fires? And you have different customers needing different things. These are quantifiable. These are real. These are the measurements of those services in the Los Angeles water system after the 1994 earthquake. You can see how many services we lost and how long it took to restore them. And you can call a concept of operability, the system is operable to every customer that receives all 4 of those services. And those services can be restored before everything is repaired. So functionality is a measurement of how every component in a system works together so that you can provide these, but it includes a lot of redundancy. And there's a lot of human activity that goes into this too. But we got the 60% functionality, meaning that we still had another 15 years of repairs in Los Angeles, but in 12 days we were able to get everybody the services that they needed. What does that mean in terms of community resilience? With respect to the water, everybody was restoring themselves to normal activities at 12 days after a very significant earthquake. That's pretty good. We were resilient to this event. We won't be resilient to all events, all earthquakes. Many are going to be much bigger than this and also might strike in more vulnerable areas of the city. But you can measure these, so we can actually use this as a marker for improving our resilience. So back to a portion of the definition. A resilient water system provides the services to customers and users when they need them during a disaster. So again, the hospital is not the same as the sports complex. So that requires knowledge of which basic services that I just showed, which ones of those are needed by customers. You don't need potable water to fight a fire. So if you have a fire, don't hold back the water because it's not potable, just because houses need potable water. In the United States, we have a boil water notice. I don't know what they do here. I know in Japan they don't have that. That's a risk management measure that temporarily allows, with approval, to hand over the water quality requirement to the customer for a very short period of time. Boil your water, put iodine tablets in it, use chlorine a little bit to purify it for a very short period of time during a disaster. So you can do this and fight fires, same time, right? So we just have to do things in an alternate way. That's a resilient activity. Prioritizing the importance of customers and users for the community resilience. Again, hospital versus recreation center and everything in between. Who gets what and when, and how easy is it to get them? It's a difficult prioritizing process, but we can do this. And designing components based on the customer importance. We need to think about the supply chain from source to service, and not just because it's a bigger pipe doesn't mean it's more important. I can show you in the city of Los Angeles that a 12-inch or 6-inch service connection in some places are much more important than some 10-foot diameter transmission lines, because the service connection might be going to a really important hospital where the 10-foot diameter transmission line has a lot of redundancy, and we might be able to get the water elsewhere. So different ways to think about it when you're thinking about resilience. So components supplying the water to the customers that are most important for public health and safety need to be designed to a very high level relative to the standards. for the standards. And those that are important for community resilience that might not be so directly related to public health and safety to another level. Those that don't meet those two requirements, okay, so maybe you go for services to the recreation center for a little bit longer. Fair enough, but that might be an important economic activity in some cities as well that you need to be thought about. So we know that the systems can be broken down in subsystems. I like to think about it in terms of raw water supply, treatment, transmission, distribution, and recycled water, or reclaimed water, whatever you want to call it. They're made up, you can each have your own definitions, but they all have different components, and those components interact, and these subsystems interact. All of these components need to be designed to withstand the hazards that they're exposed to. I'm going to give you a quick example of water pipeline examples, but you could think of this in the context of all other components in the system. So a buried water pipeline performance influences the ability of water systems to provide services to customers, right? Coming from the treatment plants, coming from the reservoirs. It's important to consider the potential impact of the hazards on the pipeline performance, as well as the response to the water supply networks. It's not just the single pipeline. You don't worry about a pipeline. You got to worry about how that pipeline interacts with all the pipelines around it, and the tanks and pump stations and treatment plants. And the pipelines need to be able to resist the forces and the displacements, like a landslide, the wave propagation, induced by the hazards consistently along along with the other components. So let me introduce to you something that I led here for the past few years. It is just recently finished, but we formed an international hazard resilient pipeline research panel, and consisted of 9 experts. 3 of us are here in the room, Professor Wham, Professor O'Rourke, who will speak next, and myself, and then others from the United States and several from Japan. So from 21 to 23, we investigated the use and needs for hazard resilient buried pipelines. And we developed a process and a matrix that you could find and download here at this reference. And this is the matrix, and this is the process and the outline next to it. I'm not going to talk about hazard resilient pipelines because the next 2 presentations from Professors O'Rourke and Wham, respectively, will get into more details on those. But what are we doing here? We're listing the types of hazards that we expect, the common types of hazards that affect buried pipelines, how they affect them in the next column, then the types of impacts to the structures, and we rate them by 1, 2, or 3 axes based on the likelihood. 1 axis lower likelihood, 3 axes is higher likelihood. The likelihood of service disruption from these hazards, again, 1, 2, or 3 axes, and then the potential service disruption based on low, medium, or high L, M, or H. So I'm not going to go over this in any more detail. If you're interested, please feel free to download it and contact me as well, or others. And then you have these. You have this outline that, for sake of time, I'm not going to go through the outline, but it's a standard risk management outline where you identify your hazards, place your pipes, hazard location and pipe location, and you work your way through a risk management process and identify which hazard resilient materials you should use and then implement them. So I'll leave it at that. You can refer to that in your diagram or your book there. And then you think about it again as a network. So you need a supply chain of pipelines and components, the tanks and reservoirs of treatment plants, that match the needs of the customers. So the hospitals, the supply chain from source to service connection for a hospital should all be designed to the same highest level standard. If you have a weak link somewhere in between, whether it's exposed to a hazard or not, because there's a lot of unknowns in there, then you're going to lose your services. You don't want to lose those services. And so you can categorize these based on different levels in the way you want to view your customers within your system. You can integrate that with your asset and pipe replacement programs. So you could think about this not in a budget cycle of 3 or 5 years, but decades and even 100 years. We built these systems over 100 years. We can replace them and make them more resilient on a daily basis, but over the next 100 years, because we can't do this overnight. We don't have the money to do this. And so you think about it in terms of the long term, then it becomes achievable. If you think about it in terms of short term, nobody can achieve it. And so then you just say, well, there's nothing I can do about it anyway, and you move on and you never create a resilient or sustainable system. So we do need to think about it in the long term. So I'm going to conclude with this slide. This presentation, like I mentioned earlier, it focused mostly on what is needed to improve water system resilience. There was a little bit identified about how, but I barely touched the surface on that. And so I give you some references already, and this list of references, and there's hundreds more. This is just a few that I commonly refer to, or actually mostly self-gratification. You see Davis et al. On most of those. So anyway, these are some that I have created through this thought process, and I leave them for you. They're in your book. So thank you for your time.
Thank you.